Okay, so this curve here has got stationary points at plus and minus a, and we've got to find the value of a. So we're going to have two results the same, so it sounds like we're going to end up with a square root of some sort. Right, so if we go, and first thing to do is to turn 1 over x to the power of minus 1, 27x cubed. If we differentiate that, minus 1 times x is minus 1x to the power negative 2, and 327's 81x squared, so we get that, and we want that for a stationary point to equal 0. Now in order to solve that for your value of x, we're going to have to play around a little bit with our equation. So let's put this back into a fraction first of all. Minus 1 over x squared plus 81x squared equals 0. Now we've somehow got to get all of these on the same playing field. So if we add 1 over x squared to both sides, that would give us that. And now hopefully you can see that we could multiply both sides by x squared, and that would give us 81x to the power 4 is equal to 1. And then if we divide by 81, we've got 1/81st. Doesn't sound very nice, but the quad root of 81 is 3. So when we do the quad root of 1 over 81, that's actually going to give us positive or negative, because it's an even root of a third. Therefore a is going to be the value of is our 1/3. The next part of this question asks us to sketch the graph of y equals 1 over x plus 27x to the power 3. And in order to do that, we need to find out the nature of those two stationary points that we've just discovered about, when x is positive and negative 1/3. So to do that, we're going to do the second derivative. So we know that dy over dx is equal to negative x to the minus 2 plus 81x squared. So if we go to dy over dx squared, we can say negative times negative is a positive, so that'll be 2x to the power negative 3 plus 2 81's are 162x. And what we need to do then is find out what this is when x equals positive 1/3. We're going to get is going to equal, well, if we put in 2 times 1/3 to the power negative 3 plus 162 times 1/3, we get 108, which is positive. And remember, positive means local minimum. So that, and then we do the same again. Let's not worry about sketching it yet. Do the same again when x equals negative 1/3. We're just going to change all of those to negative ones, and we can just work that out in the calculator and put down what answer we get there. And I got negative 108, which means a local maximum. Now when it comes to sketching that, it might get a little bit confusing. Let's have a little go at it on its own. You can always put it into a calculator, and we'll do that in a minute to see what that looks like. But so let's just make a our y thing there and x here. So we're saying positive a third, if we call that bit there 1/3 and negative 1/3, it's saying that we have got a local maximum at this one. So that means that it is doing something like that there, and here it's doing something like that. Now how are they going to come together? Takes a little bit of thinking about, doesn't it? So pop it in your calculator and hang on, go to graph 5. Right, so pop it in your calculator like that, press draw. Now in order to do this, you notice I've changed the x there to be between -1 and 1, because that makes it easier to look at, not quite so pointy. You can see what's happening here. You've got an asymptote at 0, and it's there and there. That's because you've got the 1/x coming in to play on. So when it comes to sketching it, you'll then do that. And obviously in the exam, it's absolutely fine to use the calculator to help you work out what's going on, but they are going to want to have seen your second differentials there, and you identifying your local maximums and your local minimums. Okay.